Hello everyone, welcome to this teaser video for the Risk and Fraud and Analytics elective course. I'm Professor Manuel Gadi, and let me explain how the course will go and what it's about, and then maybe hopefully this help you deciding if you want to take the course or not. Well, basically the course is a journey into many different applications of risk, where we do discuss the types of risks like financial risk, strategic risk, compliance, reputation, market, credit, and technology risk, and all the related problems that they have. But we kind of dive deep explaining with data, Python, and examples only four problems that are related to those risks. So basically the first part is just an application of analytics, like the types of risks, and then the many different target variables that are problems that can be solved in the realm of risk. And then we enter the first type of risk, that is business banking. So business banking is the problem of calculating credit rating, like the agencies or country risk rating. And why is this problem here? Well, because the problem that we're solving, well, it's really known and important, and as well, it has two important things related. First, it is statistically speaking, it has a very big problem of multicollinearity. All variables that we're using are somehow correlated because they all come from the balance sheet and the P&L. They are some of them have even causality. So what are the techniques and what are the problems, or how do we treat the data to actually do a good job on the business banking side? And then another derivate from this is that nowadays we have the ESG rating, the one related to social and global goals. And then we also discuss and build ESG rating when we do building the business banking. The next one that we touch upon is credit scoring. Credit scoring is just basically what's the probability of default for you as an individual for getting a loan, a credit card, or like a mortgage. And what is the problem here? The problem is that this is very, very old thing, started basically in the 1950s, and it's basically also regulated by central banks that tell the banks how to build this thing. And one of the problems there is that when you get something so old, the banks think they know it all. The supervisors think they know it all, and then new techniques like random forest, gradient boosting, and even AI, nowadays LLMs start playing a part in this thing, but they are not prepared for the best practices that the banks have. They are not prepared for this, but the banks again think they know it all, and they do know a lot of things. So the problem here is that how do we adapt the new things that are coming from big data to the problem of credit scoring, so that we meet the requirements that they want. So this is the less technical part. Let's say we do touch on a code and Python and data, but it's less about the technical, because to be frank, to actually make a better model than the banks do with the logistic regression and the decision trees that they do using random forest, gradient boosting, and LLMs nowadays is so easy. The problem is not about beating, it's about explainability and so on and so forth. So that's what we discuss in here. There are many points that we touch when we go there. And then the next thing is algo trading. So when we say, I actually work with crypto. Crypto is where I have my PhD that in blockchain. So trading, basically want to trade crypto, but with the glasses of a risk environment. So what we do is not only trying to predict the price of Bitcoin, let's say in few days, but also how do we calculate risk measurements like volatility, value at risk, and other measurements. And in the end of the day, how do we maximize our decision based on risks? So how do we maximize our return based on risk? Statistically speaking, what is the problem with this data? First, the data is a time series. And being a time series, it has different problems like autocorrelation or not existing autocorrelation, and typical time series techniques do not work really well. So we need to go to very advanced techniques to actually overcome some of the problems and make good predictions here. And moving on to the next one, fraud detection. Let's suppose we have a credit card where some transactions are not from the owner of the credit card. How do we detect them? What is the issue here? Well, typically we speak about balance data when we have 50% of fraud transactions and 50% of non-fraud transactions. When we still talk about pretty much balance. So if we have 30% one case and 70% on another case, when we talk about 1% of credit problems, let's say in credit scoring, when we have 1% of people that miss their payments, we are talking about unbalanced data. But when we have 7 cases in every 10,000, that is 0.07% fraud cases and 99.3% of non-fraud cases, we're talking about skewed data. And in the skewed data, the problem is very difficult. Most of our techniques and methodology breaks, and then we start fighting a different enemy. The enemy is not only the fraud, the enemy is a statistic and other things that we're going to discuss right there. And what can we use it to actually do it well, fight that enemy in a good way. So that is all that. Those are the 4 topics: business banking, credit scoring, investment banking or trading, and then fraud detection that we discuss in the course. Well, the course has some group assignments. So we typically do one group assignment and one individual modeling challenge. Then depending on the version, if it's this one is full time, so there is no video conference or it's all face to face and no forum, but there are class participation. And in class participation, I do create some forums during the course where I give the activity and you need to do it, and then I count it as participation. And then obviously you have 20% for the final exam. Let me show you a couple of examples of group assignments. So a few years ago, last year, people actually worked on the type of fraud. So the type of risks. So operational risk, market risk, financial risk, and so on and so forth. And then this year, because of I'm building something with one of the groups in transition finance. So the finance that goes after the ESG rating. So how do you actually make your economy becomes less carbon or more carbon neutral? And this is called transition finance. That obviously depend on ESG rating, and that's why the work is here. The group work is like the execution or putting in place what we built on the ESG rating and so on. So it's a kind of very hot topic right now because of the changes in some countries where especially in the US, when they withdraw from the Paris Agreement. So we kind of trying to understand, get our heads around what would be the implication for transition finance and then for ESG rating. So that's where the discussions will be from the technical point of view, from the data all the way to the rating itself and the application of the rating. Why is this course important for you? Well, basically because in all types of risks, not only in banking, but in many type of companies, you do get the technological risk or market risk or reputational risk or in compliance risk, even in pharmaceutical companies. So you do get all those some of those risks in most companies out there. And most companies out there, they have a prevention department where people actually put rules to avoid the risk for taking place. But once they're running the business, the risk is in there. Some people will not pay. Some cybersecurity problems will happen. And then how do you detect? So putting machine learning models in place to actually make a live detection, that's really important. So that's where data scientists go. And then investigating, trying to trace back who created the problem, how they did it, the modus operandis. Doing that investigation also needs data scientists, people like you. And then helping the detectives or the lawyers to recover the money is also something that need help from data scientists to actually get together all the data and everything. So in all the risks, there are job opportunities for people in data science. So if you want to work in this area or if you're just curious about it, come and join us in the journey. Thank you so much. That's Professor Manuel Gatti.